Hey guys! This video is a review of properties of exponents. It's really important that we refresh our memory with this stuff if we are going to be successful with our upcoming unit. We will start by going over the rules, and then we will apply these rules to a few examples. Let's get started. If you need to press pause before you copy things down, then please make sure you do so. You may prefer to just sort of write them down one at a time, but in that case, still press pause while you're writing them down so you aren't copying anything while I am explaining how these rules actually work. I want you to listen and write separately. At the first bullet point, we have a to the m times a to the n. When multiplying like bases, meaning that the base a matches, then you need to add your exponents. So a to the m times a to the n is actually equal to a to the m plus n. A more commonly observed example is something like x to the second times x to the third. We use x as our variable most of the time. Here we have like bases of x. We add the exponents 2 and 3, and 2 plus 3 is 5. So x to the second times x to the third is equal to x to the fifth. Our base doesn't need to be a variable though, it could be a constant value like 2. 2 to the third times 2 to the q. Most people want that to be 2 to the 3q power because they just sort of want to stick 3 and q together since one is a constant and one is a variable. But you still need to add because that's what the rule says. And 3 plus q are not like terms, so you just have 3 plus q as your exponent. That's all you can do. A to the m raised to the n power. When you raise a base to a power to another power, you multiply your exponents. So that would equal a to the m times n. You may also see an example like x to the second raised to the third power. In that case, we would end up with x to the 2 times 3 power, which is x to the 6th power. Again, my base doesn't need to be a variable, so I could have something like 2 to the third power raised to the second power, and that would equal 2 to the 3 times 2 power. 3 times 2 is 6, so it's 2 to the 6th power, and 2 to the 6th power is 64. For the third example, we have a and b as a quantity inside of a parenthesis. A and b on their own are really a to the first power and b to the first power. We just don't write these invisible ones. We are still going to multiply our exponents, so we will still have a to the 1 times n, which is n, and b to the 1 times n, which is n. There's nothing further I could do in this example, so we would just stop right there. If you could evaluate, you would evaluate. The next example is similar in appearance, but it is slightly different. Since I don't have parentheses, the exponent negative n only applies to the a, not the b. B is only to the first power. Another rule that you should remember from Algebra 1 is that when you have a negative exponent, to make that exponent positive, you relocate the base to the power to the denominator if it started in the numerator, or you move it to the numerator if it started in the denominator. By relocating it to the other part of the fraction, that negative exponent becomes positive. In the fifth example, we have b in the numerator over a to the negative n. Now, if you notice, the b is not next to the a right now because the b is independent by itself up in the numerator and it doesn't need to move just because the a to the negative n is moving to the numerator so that that exponent of n becomes positive. The b will just stay in the numerator the whole time, sort of like in the last example, how it stayed in the numerator, it didn't move. A to the negative n in the denominator can relocate to the numerator and become a to the positive n. In the sixth example, we have a over b in parentheses to the m power. A and B are also to the first power, just like they were in the third example. So we are still going to multiply our exponents. 1 times m is m. So in either case, we have m as our power, a to the m over b to the m. We are good to go. Next, we have a over b once again, but this time they're raised to the negative n power. Since the inside powers are 1 times negative n is negative n, that left me with a to the negative n over b to the negative n. Since both of my exponents are negative this time, they really sort of flip-flop, trade places, and I will bring my a to the negative n down to the denominator, where it becomes a to the positive n, and I will bring b to the negative n up to the numerator, where it will become b to the positive n. I like my answers to always have positive exponents, so this is good to go. In our next example, I have a to the m power over a to the n power. Now you might think, well, this looks pretty simplified to me. What else do I have to do to this? If I had like bases, one in the numerator and one in the denominator, similar to the example we saw in the beginning, where if you were multiplying like bases, you would add your exponents. Now we're dividing like bases, so we're going to subtract our exponents. Now I like to show it this way because I break it up into two different scenarios. If the top power is bigger than the bottom power, I would write my simplified expression like this: a to the m minus n. However, if my top power was less than my bottom power, I would write it as 1 over a to the n minus m. I sort of think of it as north versus south or some sort of tug of war, and the bigger power wins and sort of pulls down that other power or pulls up that other power, and it gets subtracted from the big guy. We'll see this in class when we do a bunch of practice problems. Up next, we have a to the 0 power, and some people just go right ahead and memorize that this is equal to 1. But I think it's important we understand why it's equal to 1, so let's go back to our last example for a second. We could also do this with x to the third over x to the third. In this case, both powers are the same. Whenever you have something over itself, we know that that is equal to 1. But if we apply this rule, x to the, 3 minus 3, I could put it on top because really, who's bigger, 3 or 3? 3 minus 3 is 0. That gives us x to the 0. This basically proves why anything to the 0 power equals 1. And that is basically it for today. We just wanted to get these rules down in our notebooks, have everything organized so it can be in front of you when we sit down and work on a bunch of practice problems where we apply these rules and properties of exponents. We are doing all of this to get ready for our upcoming unit, which is factoring polynomials. If you remember how to factor from Algebra 1, that is amazing. If you feel really confident with your level of understanding of properties of exponents and you think, yes, I could totally pass any assessment on properties of exponents right now, then just go right ahead and give the video a thumbs up for your own records. But if you are not that confident, definitely would benefit from practice, would rather work with the class and with the teacher and really get this down, then give the video a thumbs down. This is just to help you stay organized and keep track of what things you are confident with and good at and what things you think you can use more practice with. If you end up going through all of the lesson videos at a future point and you realize, hey, I'm actually really good at this now, you could switch it from a thumbs down to a thumbs up or just remove the thumbs down so that you know that you've covered it and you are good to go. Hope you're ready for a lesson check quiz at the start of our next class together, where I will check if you actually paid attention to this video with a few key questions, and then we will pick up with our practice problems. Have a great day!